Swarpa said, course instructor for Geotechnical Engineering. In this presentation, we will learn about consistency, liquid state, plastic state, semi-solid state, solid state, shrinkage ratio and volumetric shrinkage. Consistency indicates degree of firmness of fine-grained soil, and it is expressed in terms of whether the soil is very soft, stiff, very stiff or hard. Soil behaves like solid at lower water content, like liquid at very high water content. That means when the water content is low, soil behaves like solid and it behaves like liquid at higher water content. Next is liquid state. When fine-grained soil, like for example clay, is mixed with large quantity of water, it behaves like liquid, and that state is referred to as liquid state. Soil behaves like liquid and begins to flow like liquid, hence it is referred to as liquid state. There won't be any resistance to flow of liquid in this state, so soil freely flows without any resistance, and it is said to have shear strength equal to 0. It will have 0 shear strength, hence it can flow very easily without any resistance. After it reaches liquid limit, it enters into plastic state. That means when water content is lowered, it will transform from liquid to plastic state. For inorganic clay, liquid limit never is greater than 100%. For organic clay and clay of volcanic origin, liquid limit can be greater than 100%. For bentonite, liquid limit ranges from 400 to 600%. Next is plastic state. When water content is decreased, that is, while drying, soil gains shear strength, and in this state, soil offers resistance to flow and will have shear strength. In liquid state, we had seen that there is no resistance to flow of liquid and it has 0 shear strength. But when it reaches to plastic state, it offers resistance to flow and will have some shear strength. And it can be molded into any shape, and there won't be any formation of cracks in this state. Next is semi-solid state. After it reaches plastic limit, it enters into semi-solid state. That means with further reduction of water content, soil changes from plastic to semi-solid state, and in this state it loses its plasticity and it cannot be molded into any shape as was being done in plastic state. And here we can see that there will be formation of cracks if we try to mold it into certain shape. Below plastic limit, soil begins to crumble when rolled into thread of diameter 3 mm. So if we try to roll the soil into thread of diameter 3 mm, it begins to crumble. That means there will be formation of cracks. Next is solid state. With further reduction in water content, soil reaches solid state from semi-solid state after shrinkage limit. Now we will find out the equation which can be used to find shrinkage limit. After we conduct the experiment to find shrinkage limit, we will have to note down the following values. First one is mass of wet soil specimen, MD is mass of dry soil specimen, V is volume of wet soil specimen, and VD is volume of dry soil specimen. Rho W is density of water. It can be taken as 1 gram per centimeter cube when the unit of mass is in gram and unit of volume is in centimeter cube. So once we know all these values, we will be able to find shrinkage limit using equation Ws equal to M minus Md minus V minus Vd into rho W whole divided by Md. And the same equation can be rewritten as shrinkage limit Ws equal to Vd by Md into rho W minus 1 divided by G. We know that mass divided by volume is density. So Md by Vd is written as rho d and rho W as this. So shrinkage limit Ws equal to rho W divided by rho d minus 1 divided by G, where G is the specific gravity of soil. If we are asked to find specific gravity of soil, we need to use this equation. So shrinkage limit is defined as the ratio of mass of water at shrinkage limit divided by mass of soil solids. Next is shrinkage ratio. With the increase in water content of the soil, its volume remains constant till all its pores or voids present within the soil fill completely with water and reaches to its shrinkage limit. When the water content of the soil is further increased beyond the shrinkage limit, soil's volume also begins to increase. So these two statements can be explained with the help of this sketch over here. We can see a soil mass of initial volume equal to V. There are soil particles shown, and in between the empty space is represented as void. When we add water to this soil mass, the water will try to fill up the gaps present in between the soil particles, that is, it will try to fill all the voids. In this process, the volume of soil will not change till all the voids present in the soil mass get filled up with water. So here we can see that till all the voids have got filled up with water, the initial volume V is equal to final volume V. And this state will remain same. That means there won't be any change in volume till shrinkage limit. But with further increase in water content to this soil mass, the volume of soil will begin to increase. So same can be explained here with this sketch, and this sketch can be remembered in order to define 4 states of the soil, that is solid, semi-solid, plastic and liquid state, and also to define Atterberg limits, that is shrinkage limit, plastic limit and liquid limit. So here in this sketch we can see that there is a soil mass to which water will be added. The water will try to fill up all the voids present in the soil mass. So in this process there won't be any change in the volume. So that can be shown with the help of this straight line. And soil will remain in solid state till a certain limit is reached, which is called as shrinkage limit. So till shrinkage limit, water added to the soil mass will try to fill up all the voids present in the soil, and there won't be any change in volume. But with further addition of water content, the soil mass or the state of soil will change from solid to semi-solid state. And in this process we can see that there is a increase in volume with increase in water content. On x-axis we can see that there is change in water content being represented, and on y-axis change in the volume. So till shrinkage limit, with increase in water content there was no change in volume, but with further increase in water content there is increase in volume. And in semi-solid state we can see that there is a formation of cracks, and we cannot mold the soil into any shape. If we try to mold the soil into required shape, there will be formation of cracks, and the soil will remain in this state till a limit is reached, which is called as plastic limit. And with further increase in the water content, soil will change from semi-solid state to plastic state. And here we can see that with increase in water content, there is also increase in the volume. And in this state, the soil can be deformed into any shape, or it can be molded into any required shape without any formation of cracks. So this type of soil is called as plastic soil, and soil will remain in this state till a certain limit is reached, which is called as liquid limit. Then with further increase in the water content, soil state will change from plastic to liquid state. In liquid state, soil will flow like viscous fluid. It is referred to as viscous fluid because there will be some resistance which will be offered to flow of soil from one layer to another layer. And in this state, there won't be any shear strength, so it is very dangerous to construct any structure on this type of soil, since it behaves like a liquid, it flows like a liquid. There won't be any shear strength for this type of soil, and there won't be any resistance offered to its flow. It will flow easily, but it will flow like viscous fluid. So to revise, we can say that volume of the soil is constant with increase in the water content. So here we have seen that with increase in water content, volume remained constant, and this state was there till a limit is reached, which is called as shrinkage limit, and after that the volume increased with further increase in the water content. Shrinkage ratio is an indicator of how much volume change is possible as changes in water content above the shrinkage limit occurs. Shrinkage ratio is the rate of % change of soil volume by its dry volume with respect to water content of the soil. SR is equal to MD divided by VD into rho W, where MD is mass of dry soil specimen, VD is volume of dry soil specimen, and rho W is density of water, which is 1 gram per centimeter cube. Next we will define volumetric shrinkage, which is also known as volumetric change. It is the reduction in volume of soil mass expressed as a percentage of its dry volume, that is VD, when the soil mass is dried from a water content above shrinkage limit to shrinkage limit. So Vs is equal to V1 minus Vd whole divided by Vd into 100%. Thank you.